All right, welcome back. Today we're going to go through your quiz review for PCM for section 7.1 and 7.2. So first couple questions here, determine the order of the matrices. Remember, order is rows across by columns up and down. So this one is a 2 by 2. Second one is a 3 by 2, and that last one you got one row and 3 vertical columns, so a 1 by 3. So again, these are kind of, I don't want to say they're softball problems, but they're designed to get you off to a good start in your quiz and get you rolling here with some points and feeling confident. All right, write the matrix in row echelon form. So you can see this is an augmented matrix. We got our x, y, and z's, and then we have what each equation equals. So they didn't ask us to write equations, but if they did, this would be x plus y plus z equal to 6. We want to get this into row echelon form, so I need zeros here. So I am going to take the top row times -2 and add that to row 2. And I am going to take this top row times -3 and add it to row 3. When I do that, there's the result that I get. And again, we're happy with that because we want zeros here underneath this 1. So again, I multiplied all these numbers by -2, added it to this middle row, and this is my result. Multiplied this top row by -3, added it to the third row, and here's my result. Okay, I want to get a 0 right here too, and you'll notice these are the same. So if I take row 2 minus row 3, these are going to cancel out and get me a 0, and that's actually going to be my next step. There's a couple different ways you can go about it, but I'm going to get this 0 here right away. And so you can see from this matrix to here, what I did is I just took this row, row 2 minus row 3. So -3 minus -3 be 0. -1 minus -4 will give me 3. And -9 minus -18 will give me 9. At this point, we're almost there. I need a leading 1 right there to be in row echelon form. So I am going to multiply this row by -1/3. And there's my result. And I am going to multiply the bottom row by +1/3. And now you can see we have these leading 1s on an angle with zeros in front of them. So this matrix is now in row echelon form. All right, number 5, write the augmented matrix for the system of linear equations given below. We don't have to solve it, we just have to write it. And so we're going to take our coefficients here for x, y, and z. So -3, 9, and 5 equal to 13. 4y minus 2z equal to -10. And 12x minus 8z equal to 7. You can put zeros in here. I didn't. For ease sake, let's go ahead and do that. Technically, we probably should. So we'll go ahead and put those zeros in there. And that'll work a lot better. Then we've got everything full. So again, don't forget to put your zeros in there. But now we have our augmented matrix for these equations. We do not have to solve this. Okay, number 6. Now we're going to work backwards and solve. It says to use back substitution, and you'll notice right here they already gave us z. So z is -2. So now I can plug that in up here. This middle equation is 1y plus 2z equal to 10. So I plug -2 in for z, and that will allow me to solve for y. And we'll get 14 for y, and once I have z and y, I can plug it into the top equation, which is 1x plus 3y minus 3z equal to -5. So you'll notice I replaced y with 14 and z with -2. And when we do that, x is -53. So don't freak out when you get that big number. That is what it is. Our math here is correct. And once you have x, y, and z, don't forget to write them, in this case, as an order triple, since we had 3 equations and 3 variables. All right, so there's page 1 of your review. We'll slide over to page 2. So we're going to use these matrices below to answer the following questions. Don't freak out when you get to number 8. That one's actually going to be extra credit, and I'll explain that in a second. So for number 7, let's just start there first of all. So try to ignore this mishmash over here. For number 7, this matrix is equal to B. So 7x minus 4 has to equal 6. So you'll notice that's the first equation that I put here. And 2y plus 5 has to equal 12, which is my second equation right there. So now we solve for x and y. I left them as fractions. If you want to write decimals, that's perfectly legit. That's fine. But so if you want to write it as 3.5, go right ahead. But leaving them as fractions is fine. All right, number 8. They actually want matrix x, so that's a matrix we're trying to find. And to find this, we're going to do 3 times x, this unknown matrix, minus 4c. Well, we have c right here. And so 4c would be if we multiplied all of these numbers by 4, and then it's got to equal the numbers in D. So again, I don't know what the x value is. So 3x minus 4 times 12 has to equal 1. And 3x minus 4 times negative 4 is plus 16 equals negative 5. 3x minus 4 times 6 is negative 24 equals 3. And then I do the same thing for all the other rows. And I solve each one for x. And so when I do that, I get these 9 numbers, and that is matrix x, which is what they're trying to find. Again, this is going to be an extra credit problem on the quiz. I mean, if you want to take a look and park here for a moment, kind of work through that. But you can see each one of these was 3x minus 4 times the value in C equal to the corresponding value in D. And so that's how we set all of these up. Most of them worked out to be integers, a couple fractions there, that's fine. But again, number 8 will be extra credit on your quiz for tomorrow. All right, number 9 and number 10, a little more similar, are easier things that we've done here. So 4a, again, we're going back up to these matrices right here. So 4a times 3b. And so what I did is I took all those numbers in matrix A, multiplied them all by 4. That's what you got here. Multiplied everything in B by 3. So that's this result. Now, they are not the same size, but we can multiply them because this is a 3 by 2, and this is a 2 by 2. So we go row times column, row times column. That's this top row. Then we do the middle row times each column. That's here. Then we do the bottom row times each column. That's your math right here. So this is the work that I did, and I ran out of room down here. So this is actually what it equals when I do 4a times 3b. So this is my result right there. For b squared, so matrix B is right here. We multiplied it by itself. So again, don't just square these numbers. That's not the correct answer. You're taking row times column, row times column. And then same thing for row 2. Row 2 times column 1 right there. Row 2 times column 2 right here. And there is your answer for b squared. You can certainly use the calculator if you'd like for this. Just make sure you verify by showing your work there. So especially with number 9. Typically if it's a 2 by 2, we want to see the work by hand. Once you get larger than 2 by 2s, we're okay with the calculator, but make sure you write that out to show your steps. All right, matrix multiplication. Again, don't break rule 1 here, okay? So we know row times column, so 3 times 3 is going to be 9, and 6 times A, and that's going to equal 21. And then we do the same thing down here, 3 times B, and negative 5 times 6 is going to equal 19. So again, row times column equal to 21, row times column equal to 19. So I've got one unknown in each of these. So here I'm solving for A. Over here, obviously B times 3 is going to be 3B. Add 30 over and divide. You may get a fraction, that's fine. You can leave it as a fraction. No need to change that to a decimal. You certainly can if you prefer, but fraction's fine. All right, page 3. This is a little different than what we've done before. As you can see, it says matrix M represents the vertex of a triangle. So here's what's going on with that, just so we're aware. This matrix represents X and Y coordinates. If you have a triangle, you really got 3 vertices, or 3 points. So we've got negative 5, 3, 2, negative 2, and 4, 5. So these are the 3 vertices of our triangle. X coordinates in the top row, Y coordinates in the bottom. You could do this for any shape you want. All right, so what matrix represents this image if we translate it down 3 and left 2? Well, if you're going to move something down 3 units, you're going to subtract 3 from all of the Y's. And if you were going to take a point and move it left, the way you'd go from 5 to 3 or 0 to negative 2 or 10 to 8, you would have to subtract 2 from all of the X values. So that's going to be our translation here. So this is the matrix they're looking for. Now, how did I get these numbers? I took all of these X values and subtracted 2. So that's this row. And took all of these Y values and subtracted 3. Again, because it went down 3. So 3 minus 3, negative 2 minus 3, 5 minus 3. If we would have moved it up, then we would have added. If we would have moved it right, then we would have added the X. So here's my 3 vertices. I wrote them as points. You don't have to. The reason I did that is we're going to graph that at the bottom. So we'll see that momentarily. And then 12b, it says what matrix represents the image after doubling the size of the triangle. And so what we're going to do is we're going to take our original matrix up here, and I multiplied every single one of those numbers by 2, and that gives me this result. So again, here's my XY coordinates that you see right there. And now that I have my 3 points for 12A and 12B, we will graph them accordingly down here. So with the first one, again, you have negative 7, 0, 0, negative 5, and 2, 2. And with 12b right here, negative 10, 6, 4, negative 4, and 8, 10. So we just graph those 3 points, make our triangle. So this one was twice as big as the original, and this one was moved down 3 and left 2. And then to wrap this up, we got a little bit of review here. Notice right here we got a cube root, so that's third root right there. A cube root of 27 is 3. You can do that right in your calculator. 3 will go into 4 one time with 1 left over, so 1x stays under the square root. 3 does not go into 2, so y squared stays here. 3 goes into 8 twice with 2 left over. 14, our division, 15 divided by 3 is 5. There's only one x here, so it stays x squared. Y to the negative 4th will move up top, so y to the 4th. And with our z's, 4 minus 2 is z squared. And then our last one here, we're dividing. Remember, when you divide fractions, you're really multiplying by the reciprocal. So you can see I changed this to multiplication. Took the reciprocal right here, so x plus 7 up top, x minus 4 on the bottom. And you're going to want to factor this one here. So this top one factors to 2x plus 3x minus 4. The bottom trinomial, x plus 7, x minus 2. That will help you with your canceling. You can see that the x plus 7s cancel out, and the x minus 4s cancel out. So what you're left with is right there, which is your final answer. So that's your quiz review. Again, don't forget to stop by our help session if you need to for questions on this or questions on the quiz to get started. And we'll get after it. All right, thanks.